Okay, Grace, here is part of our virtual lab meeting for this week, I guess. I'm going to basically refamiliarize myself with what we talked about last week. I just read your email, which you can see is up on the screen here. That is invaluable, so that's great that you did that. This summary. So looks like we basically ran some tests on an SPSS sheet that we felt like we could trust, and we didn't get any significant results. It's just hard to believe to me that there's really nothing here. I mean, I don't know. I mean, it used to be that when I studied schizophrenia with Yu Chen, we would like always find something different. And maybe it's just that schizophrenia is such a more severe brain disease that it really affects the entire brain more so than depression does. And that's why we would always find something then and we're not now. So maybe that's just the truth. But it also kind of makes me want to keep looking to see if there's something that we haven't just considered yet. So I'm saving your thing here. Under research. The Holy Grail is a good name. It's pretty unmistakable. I'm hoping I can click on it and it's going to work. I don't think it's going to work. I think it's trying to open up with the wrong version of SPSS, maybe. Oh, yep, seems to be happy. Okay, good. All right, so let's see what you put in here. You got all these values, baseline, this, and same, that, and opposite. All for the different coherences. And then we have the thresholds for each of those. Okay, lovely. And then we even have a CSS score and a CSF score. Then we have med stuff. My goodness. That really is most of the stuff you think to want to look at. Why do we have 3 groups? Oh, one of them is remitted. I can't remember which group is which. That's okay. Doesn't really matter for right now. Here's one thing I want to try, which is I want to look at the data at a case-by-case basis. There's a sense in which this is the best way to understand anything is at an individual level. And this isn't really understanding it at an individual level, but it's understanding it at a group level that is much richer than just looking at means. So what I'm going to do is copy all this stuff to an Excel document. And so it's basically, actually I copied way more than I probably need. I think I have a group, and then I have a bunch of accuracy stuff. So it's kind of like 1, 2, 3, 4, 5. Yeah, it's probably going to be 15 rows in a row of like accuracy stuff. And then it gets to threshold, so I'm going to delete 15 rows here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That looks right. And then now we just have a little bit more manageable set of stuff. So this is probably the base thresh. What's the next one? Same. Pop, CSS, CSF, BDI. All right. So what I want to do for starters here is I'll sort by And now I'm back in groups. And what I want to do is insert a value here. And just say equals rand, which I believe is going to give me a value from 0 to 1. So if I were to, whoopsie, not copy it down 100,000 rows, but just copy it down 88 rows or whatever we have. For some reason we only have 74 here. Do we really only have 74 pages? Why are we missing like 18 patients? Did we just throw people out? Did we throw out that many people? It's possible. It's probable. I just want to double check, so let me know if you have a thought on that. Okay, so so this is a random value between 0 and 1, so I will now divide it by, say, 5, and I'll subtract it. So I'll take point 1 and subtract to that. So basically what I'm trying to do is get a bunch of random numbers between like 0.1 and negative 0.1. And so then what I'm going to do is add that to this. No, that one. And this is to create a scatter plot. That's why I'm doing this. I may be able to think of a more succinct way, but this is the best way I've been able to come up with. And so what I'm going to do now is, I mean, Excel is so disgusting. I guess I'll just do it in Excel for now. Insert charts. Select data. We'll see how this looks. I might have to do it in MATLAB or something. So I call this baseline brushes. And the X is going to be this little thing we just made. So it's basically values around the group value, 0, 1, 2, or 3. And but they spread out a little bit so that we can see the individual values better. And now we're going to look at the baseline thresholds. Hey. Okay, like this. This is nice. So it does look like sort of there's two outliers in this group and in this group. That's effed up. How good the remitted. I think group 3 is probably remitted depressed, right? Or did we make it so that that's actual depressed? But in any case, whatever group 3 is these are. I don't know if these are statistical outliers or not. But I also don't really know. I wonder if we could add the means to this plot. So if I just said, so if I did like a 1, 2, 3. Oh, and every time I hit enter and anything, it shifts. Its random values are recalculated, but it still looks the same. So if I said equals average, and then I said equals standard deviation, and then I said equals standard deviation divided by the square root of the number of observations, this is the standard error. And then I'm going to have to do it again. just did a little funny trick that I discovered in Excel. Feel free to ignore. Or if you want to run Excel tricks, go back and see what I did. Okay. So I just actually, turns out I'm an idiot, and I just took the average of these random values that we just generated. Not too informative. Fortunately, what we can do is just copy it and paste it over one, and now it refers to the baseline. The nice thing is we can then reuse these formulas for all the other things we're going to end up graphing in a minute. So what I want to do now is add a plot. How do we do that? Series name. Needs. X values. Boom. Y values. Crap. That was the Y values that I did for the X values. The X values are here. The Y values should be here. Crap. Y values are not the standard deviation, so that means that one's much better. Okay. I wanted to have error bars on these bad errors. I don't know what's going to happen. I don't know if it's possible with this type of plot. This is why Excel is terrible. One of many reasons for graphs. It's very powerful for spreadsheets. But. All right, so it does appear that they're trending downward. Let's see if these are statistically actually outliers. So if I said average, oh, well, I have my bloody averages right there. And I have my standard deviation. So the way you determine if something is a statistical outlier is you say the average minus 2 times the standard deviation. So that's our lower bound for whatever this first group is, normal controls, I think. If there's any thresholds below -1, which I'm pretty sure there won't be because it's not physically possible, they would be an outlier in the terms of being too low, in the sense of being too low. The upper bound would be to the mean plus 2 times the standard deviation. And the upper bound now is 0.5. So we do have 2 outliers in the normal control group way up here. Whoopsie. For the patients, we also have some. Everybody's got 2 outliers, it turns out. It's interesting. Oh yeah, it's really, these 2 are really affecting the mean for the normal controls. But 0.49, anything above 0.49 for the controls is an outlier. Anything above 0.43, which would include these 2 for the middle group, is an outlier. And so basically all these every group, you chop off the top 2 if we want to remove outliers. I don't think it's going to make a difference, but let's see. Like this person would be gone, and this person would be gone. They're still looking the same. Everyone's got pretty much the same. But this person would be gone. There's no variation. Oh, there's a little variation. Are these two supposed to be gone? Yeah. I think there was one more that I didn't catch in the depressed group, or in the number 2 group. That person. So now if we look at it, it's more or less the same trend as it was before. I mean, these groups are really equivalent, and that one goes down a little. And this is interesting. There was, if you'll recall from a long time ago, I don't think we've talked about this in a long time, but Yu Chen really believed that the depressed people were better at low coherences than the controls were. And I guess it looks like that's not driving them to have a lower threshold because they weren't better at higher coherences. Just at like the 8 coherence or something, they were better. So they were seeing a signal that the controls weren't seeing. They weren't getting above 80% accuracy, but they were like well above chance when the controls weren't. But that's not really playing out. Sometimes that's called like a sub-threshold perception, and it's not really affecting what the threshold is, because when you fit the curve, you know, it might be ignoring that point to a degree, or it's not really affecting the shape of the curve that much. So that signal is not coming through here. And I'm going to undo my deletions here. I don't know, it looks like the controls are the worst, which is cool. But then it goes just ever so slightly down. And the controls are 24, a threshold of 24, versus a threshold of 20, and the standard errors are 0.2, so yeah, it's not going to be significant. That's for the baseline. Let's see what it is for other stuff. So this would be the same. Sorry, what am I doing? Not in the X data. Maybe eventually we can do all the calculations. 1, 2, 3, 4. 1, 2, 3, 4. Something like that. There's a bunch of people at the top for the same. They can't do it. It's interesting. This third group here, though, they do have a bunch of people who are this. If you kind of ignore the people that are at the top, who basically can't do it. It's funny. There's no one who is in this zone here. I wonder if you clipped these people, it looks like this group might be lower. I don't know. Let's. In fact, let's. You don't have to necessarily graph it. So this is the trick I was doing before in Excel. What you do is you copy and paste, and oh crap, this is referring because it stays in the relative. It's like eight columns over, whatever. You know. So what you do is then you just do it again. Skip one, boom, and you cut. Oh no, sorry, you don't do that. You take this thing that you just pasted that's now referring to the wrong one. You cut it over. Now it's still referring to that same wrong one as it was before. And then now you paste it back. And lo and behold, what you've done is exactly replicated the exact formulas of the original one. This may be completely obvious to you guys, but I've never seen another human being do this. It's a little trick I came up with on my own, which I'm very proud of. Okay, so now we should be referring to, then I just pasted it over one. So now I copied and pasted it over one. So now it's referring to the same stuff. The same condition. So I'll just move this over. suppose I'd like to add the means. Look at that. So here it's going down again. The means are going down. The controls are the worst. Interesting. What's this stuff? Oh. This is the one that I pasted. This is the S. What is this? That's square root. What's this? Oh, this is the outlier bounds. Whoops, I did want that thing. Here we go. This is the upper outlier bound. So anything above 0.8 or 0.7. So actually, there's no statistical outliers in this graph. Okay. So that was for the same. What about for the op? That's not our primary research question. But let's look at it anyway. Gotta find something. There's got to be something going on here. Because depression, it really probably does affect your whole brain, maybe in a more subtle way than schizophrenia does. But when someone's depressed, it's really this profound experience. I really believe that if there's these things happening at the level of, your HPA axis, your hypothalamic pituitary adrenal axis, there's hormones flowing around and chemicals, and they're washing through your whole bloodstream. I just think that maybe it affects perception somehow. So let's keep hunting. I have to go to my faculty in a couple minutes. I suppose I could let you do this, Grace. Now that you've seen what I'm doing. Right now I'm having so much fun, I don't really want to stop. But okay, that's the op. I'm gonna call it op. Shall we? Well, I guess we shan't because it's not letting me type. Again, Excel. Can I just type it, please? Okay, and then now I realize the other ones don't even have a title. Oh, well. So now we'll just repeat our trick. I think I probably deleted one too many. Oops. I think I deleted this stuff. Just double check this is referring to the correct column. No? Oh, there you are. Good. It's got an interesting idea. What if we plotted the 3 for each subject? That might be fun. Let's do that. Do that in a second. All right, so these thresholds are hella low. Look at this, 12, 15, 15. These are 40. And these ones are 20 in the middle. So, I mean, this is obviously the opposite condition. It really facilitates perception. It's one way of looking at it. So, that's cool. Look at that. There's one person in each group who sucks at this condition. They are definitely going to be statistical outliers. Bet your bottom dollar. Yeah, anything above 0.4 in any group is going to be a statistical outlier. So if the controls have 2, this one, and this one is really an outlier. And this actually is not an outlier, but this one is. So if we chop those off, all right, let's add the means to the graph. It is rather difficult to say anything about these graphs. First of all, they have no error bars, but I'm not seeing anything compelling. I mean, this one here is the only one that sort of does look legit, that controls really do have more. If you clip all the people, like, I wonder if the people that are up here, they basically have a threshold of 64. Maybe they didn't fully understand. Like, they understood how to do the task because they were okay in the other conditions, but there's this feeling you can get when you're doing the task that makes you kind of get it, like get how to see the thing in the middle when the surround stuff is there. And like, I think part of what we're measuring is the degree to which people kind of experience that, like, oh, okay, I get it. Like, I get how to pay attention to the stuff in the middle when the stuff on the surround is there. Like, we try to use words to explain, but it's a very nonverbal experience, and sometimes I don't think people fully got it. So I wonder if a lot of these like ceiling folks here are. It's more of a like if we had another hour with them just doing demos with this, we could have got them to understand better, and they would have performed a lot differently. Whereas this might be more measuring stuff that's happening in area MT in their brain. Like, I don't know, and maybe not. But if we did clip these people out, it does look like this group is kind of this even distribution centered around here, and this group looks lower. I don't know if there would be a difference here, but between this group and this group 1 and 2, but 1 and 3 do look different from each other. But, you know, we're looking at a lot of comparisons, so maybe that's just noise. All right, here was my other idea. Let's see if we can quickly do this, see if Excel can do a good graph for us. It's unlikely. Actually, yeah, let's switch to math. I don't know which group is really which, so I'm just going to call them group 1 and group 2 and group 3, and then I'm just going to paste in the base, same, and off stuff. Base, same, and off. And I'm trying to do what's called a spaghetti plot, where you draw all 3 data points for each group, for each subject, all on the same graph, and you get to see. It's a way to kind of see patterns and stuff. I like it. I like to show all the data. It works very hard to get it. And you might as well share it with the world in a detailed but concise way. So here are our data. And we're just going to say plot. What if I just said that? Plot G1. And we'll do like just lines. We'll make group 1 black. I just did that for starters. DD plot. Doesn't like spaces. Ooh, good night. What it did is it plotted in a very strange way. I think it plotted hallways. What if I just do this? All right, yeah, so this is what we want. Oh, and we should reorder this stuff. Crap. Can I do that? I cannot. I have to switch it here. I need baseline in the middle to really see this. Same on the left. Opposite on the right. I'm running out of time in another 5 minutes. But we must see the spaghetti plot before the faculty meeting. Sounds so all right, copy. G1. G2. G3. Now, the phone is ringing. Okay. AD. Hello? Hello. Oh, yes, my pleasure. I've got to run. I'm in the middle of something and I'm recording a video of myself. All right. That's good. All right. So that's like that's the whole pattern for controls, I think. There's a few people that are kind of the opposite. Like, what the hell's going on here? Getting worse? Or they do better, and then here they do better than baseline? We should check to make sure those aren't like mistakes, because that is kind of surprising. That's one thing we should do. Let's do it like this. We do a figure with subplots. This will be subplot 1. I was gonna, that's why I made it black, but we'll just do. We can't put them all in the same graph. That'd be too much spaghetti at once. We'll do G2, G3. What is this? I don't know which group is which. Oh, look at that, didn't work. Got to change the value. So this will be the second plot. This is the third plot. All right. Wasn't quite as helpful as I was hoping. It is surprising. how many people were not facilitated by the third condition? And how many people got worse? Going from the... You should get better when you go from the same condition to baseline, like from 1 to 2. You should get better, like this thrust here. And most people do, but there's what? You can count them because you can see the upper sloped lines. There's only 3 blue ones. So 3 blue ones. But for green is 1, 2, 3, 4, 5. And for black there's 1, 2, 3, 4, 5. Okay, so there's about the same for each group. I think that's just what we should expect. Alright, well, we're just, methodically going through this, beginning to get a sense of the data. So one thing we can do is check these, but other than that, we could just kind of continue poking around. And I'll send you this